Hello all. All over the world, MySQL is running in just about any environment you can think of. From small businesses on AWS to the large enterprise on ESXi and back down to your average home labber running MySQL on an Intel NUC. MySQL, or the increasingly popular fork, MariaDB, is the de facto standard open source relational database management system. However, in recent years, NoSQL databases like Mongo, Redis, and Amazon's DynamoDB have been garnering significant attention from the younger, more hip crowd. Now, I may be young, but I still like the MySQL MariaDB relational database paradigm. In fact, I actually think the young crowd would be more interested in MySQL if they knew just what it could do. For example, did you know that you can use MySQL as a file server? That's what we're going to be doing today on Enterprise Home Lab. To accomplish this simple but incredible feat of computer science, you're going to need a couple of things. First is a Linux machine. I'm using Ubuntu 22.04. Next requirement is a MySQL or MariaDB server, and they're the same thing. MariaDB is a fork and basically a drop-in replacement for MySQL. I already have that set up, and there are a ton of videos explaining how to install a MySQL server, so I'm not going to go over the installation of that. Once you have those prerequisites ready to go, you're going to need to install a couple of dependencies on your machine. Note that this can be done on the same machine or different as the MySQL server. To me, this ridiculous setup only makes some sense if the client and server are separate machines, but realistically, there's no issue with them being on the same one. So on my Ubuntu, I'm going to apt install build essential, libmysqlclient-dev, libfuse-dev, git, libtool, and autoconf. And basically that just provides our system with the tools and libraries that we need for compilation. Up next, we need to actually pull the repository, so I'm going to git clone github.com/byanster/mysqlfs to grab the project files. Now, there are a couple of issues in the code that we need to fix. The repository was last touched last time I checked in 2011, so I don't know if these issues are related to newer versions of GCC or make handling things differently, or if the code actually just doesn't work, but I'm going to go with one of the first two. So basically all we need to do is cd into the mysqlfs directory, and we're going to see this pool.c file here. We're going to edit that. I'm using nano-c. That -c gives us a line number at the bottom of the screen here. And that's going to be helpful because we need to go down to line 54. And this mybool reconnect equals 1, we just need to change that to int reconnect equals 1, and that'll do. So I'm going to save that. Now we're going to follow the next two steps from the repository's README. We're going to run autoreconf-vfi. And we see a few warnings here, but we can ignore those safely. Now we're going to run configure. Okay, if we try to run make now, we're going to get an error about a variable being set but unused. We're actually going to get a lot of those. This is because GCC wants to flag all warnings as errors, given the configuration that is set up here. Given the impracticality of this exercise, we can throw caution to the wind and just completely ignore those. To disable this, we're going to need to edit the make file, and it should be on line 286. We just need to delete the -w error flag. We're going to go ahead and save that. Now we can compile. And that should be it. Now, if that worked, you should have a MySQLfs binary in your directory. So we have ours right here. Now we can log into our MySQL server and create a database and credentials for our file sharing user. To create the database, we're just going to run create database MySQLfs. Then to create the user, we're just going to run create user MySQLfs user identified by password. Next, we need to give permission to our new MySQLfs user to select, insert, update, and delete on our MySQLfs database. And we flush privileges. Back in the project directory, we'll see this schema.sql file. This file defines the table structure that MySQLfs needs. So we're going to take this file back over to our MySQL server and import it into the database that we just created. With that pasted in, we're just going to import that file into our database. And to do that, we're just going to run mysql-uroot, then our MySQLfs database name, and we're going to pipe in our schema.sql. And that creates all the tables that MySQLfs needs. Now, we need to do one more thing over here, and that is create a mount point. This mount folder is where we're going to mount our MySQL storage. Now, we can mount our MySQL server to our local folder with mysqlfs -ohost equals, and then the IP address or host name of our MySQL server, -o user, and then the MySQLfs user we created, -o password, and the password we created, -o database with the MySQLfs database name we created, and finally, our mount point. We can go into our mount point and see that there's nothing here, but that's not fun, so let's create a file. I grabbed some just placeholder lorem ipsum text, and we're going to place it in a file called test.txt. If we go back into our MySQL database and run a quick show tables, we see that there are now 3 tables: data blocks, inodes, and tree. Let's take a quick look in data blocks and see what's there. We see that there's one row in the set, and that row is the entire file that we just created. If this file was bigger, it would be split into multiple blocks. Now, MySQLfs can also handle directories. If we run describe tree, we can see 3 columns: inode, parent, and name. So let's see how this works. Let's go back to our mount point, and we're going to create a couple directories. So we've gone 3 directories deep. Now, what does that look like in the tree table? The name column represents the name of a file or directory, and the parent column indicates that a given file or directory is nested inside of another. We see that our root directory is mounted as inode1, and our test.txt document, its parent is inode1, so it's a child of the root directory. Our child folder, its parent is inode5. Well, what's inode5? The parent. And the subchild, same thing. Parent is inode6, and that just happens to be the inode of the child folder. So MySQLfs is storing data the same way that normal file systems store data on a disk. It's broken up into blocks, and directories are just files that point to other files. If we go back and delete the file, we can see that the tree records and the data blocks have all been deleted. Now, what about bigger files? Well, it stops being useful there. In testing, I saw a throughput max out at around 1.5 megabytes per second. Now, this is actually more than I was expecting it would be. I was expecting something in the kilobytes per second range. Unfortunately, you really couldn't do anything useful with this, so what's the point? While MySQLfs isn't a great tool for file storage, it is a great exercise for learning about Fuse file systems and even file systems in general. If you're looking to learn about Fuse or file systems yourself, implementing a simple project like this would be a great way to do that. I've been experimenting with all things Linux for years now, and I figured I'd try to share some of what I've learned. I have quite a few other videos planned, and most more educational and practical than this one. If you're interested in this sort of thing, please consider liking and subscribing, as it helps the YouTube algorithm recommend the video to other people with similar interests. Anyway, happy experimenting, and thanks for watching.